So yesterday, just kind of quickly recap, we started looking at our power series as functions. So we saw that we could take integrals and derivatives of our functions. One piece that's going to be very important for us today is that the radius convergence is the same as the power series, regardless if we take a derivative or integral. However, the interval of convergence may differ. So we will have to test our endpoints. Okay, so we went ahead and saw that we could take derivatives of power series. We even took the third derivative of power series. And the last problem we did the derivative and an integral. First problem that we have for today, problem 5, this is not a lost my train of thought for a second. This is not a derivative or integral problem, but they do want to represent the power series for the function e to the x squared. So what we would first want to do is, what is the power series for e to the x? List that one out. Once we know that, we should be able to then list the power series for x squared, e to the x squared. We have done something like that before. We saw what if we had like sine of 2x or e to the negative x in the previous lesson. So I want you guys to take a couple minutes and talk to each other on that one. What would be our e to the x power series? And then what would be e to the x squared? How would we set that one up and then simplify our result? All right, so take a couple minutes and then we'll check in. What is the power series, expanded power series for e to the x? I'll start it out. It starts with 1. 1 plus and we'll go ahead and say plus dot dot dot, and then what's the nth term? Plus dot dot dot. All right, so then what would we do if we want to do e to the x squared? What was that? We don't want to square the x, because that would mean that all I'm doing is saying, oh, that'd be squared, that would be squared, that would be squared, and so forth. And that, though part of it would be true, not all of it would be true. So not necessarily we're squaring the x, but what am I doing with x squared? We are going to plug it in, okay? And there's a key difference between those. Some places it might end up being the same, but we want to be careful that we're saying that we're plugging it in. So that's going to be x squared, so 1 plus x squared plus, and then here I have x squared plus, and then we have x squared to the third, 3 factorial, plus x squared to the fourth, or 4 factorial. And I guess if we just squared everything, it might end up being the same, but we want to make sure we're writing it out correctly, because our work is also important. And then this one would be x squared to the nth power over n factorial. All right, so our f of x equal to e to the x squared would be equal to 1 plus, what would be our next one? X to the fourth over 2 factorial plus x to the sixth over 3 factorial plus x to the eighth over factorial plus dot dot dot. And this one would be 2n over n factorial. Okay, so if you just squared everything, yes, technically things would come out, but it is also how we do it is also important. Our work does matter. All right, so that was problem 5. Problem 6. we have let k of x equal to cosine of x squared. Write the first three terms in the general term of the power series for x times k of x. All right. So this one, we did do ones similar to this. You would want to say, okay, first off, what is cosine of x? What is that power series? Then, what is cosine of x squared? Similar to our e to the x. What is that power series? Once we have that, then we should be able to do x times cosine of x squared, which is our x times k of x. All right, so go ahead and try that one out as well, and we'll check in a couple minutes. All right, so let's go ahead and see what we have. Start with our cosine of x. Adrian, what is our power series for cosine? Okay, so there we go. All right, so that is our cosine of x. So if we do cosine of x squared, what am I going to do for each of my x's, Adrian? All right, good. So that is cosine of x squared. So now we need to do the x times cosine of x. So let's do x times cosine of x squared. So x times all of this. So then what am I going to do with that x, ladies and gentlemen? Distribute it into all those infinite terms, right? So we have negative 1 to the n, x to the 4n over 2n factorial. All right, so we go ahead and distribute it in, and we have, what's our first term, guys? X minus x to the 5th over plus x to the 9th over minus 15th over plus dot 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 plus, we have negative 1 to the n. What would be our power on this x? Let's see what that would be. So it would be x times x to the 4n. That is x to the first. What do we do our third powers when we multiply bases like that? Do we multiply the powers, add the powers? What do we do with those powers? We add them. So that should be 4n plus 1 in the power. Okay. So then we have our kx times k of x would be all of that. So I'm just going to rewrite it. I could probably copy and paste it down, but I'll just rewrite it. And then in our nth term, we would have the 4n plus 1 as a power. So that'd be 4n plus 1 over 2n factorial plus dot dot dot. Got that up here. We forgot it up here. All right, and that would be our answer. Okay. Any questions on that problem, ladies and gentlemen? We good with that? Okay. So problem number 7, we're actually not going to do this one here. I'm going to do a different one. So we are going to actually cross this one out. Cross out. Cross out. And we're going to write a new problem. So we are going to say given f of x equal to 1 over 1 plus 2 x cubed, find a Maclaurin series for f of x. So that's going to be our new problem. oh, not just f of x, sorry. F prime of x. We want the derivative. Was everybody good on problem 6? Did we still need that one, or were we good on that one? All right, so I want you to think about this one. What kind of series does this format right here give us? We saw that last week. What kind of series does that kind of format, that rational function, give us? So our geometric sum series, right? So this is in that form of a over 1 minus r. So if you're able, from that, able to figure out what is your a and what is your r, you should be able to then find a series, right? What is the geometric setup for that? A times r to the n, right? So go ahead and figure out what your f of x series is, and then if you want to try finding the derivative, by all means you can. Go ahead, at least get a series, summation series for f of x. All right, so we should have that function. Let's go ahead and check in. So what is the r, or rather, what is our a value? 1. What is our r value? All right, so we can go ahead and write that. So we can say, hey, f of x, we can rewrite as 1 over 1 minus negative 2x cubed, is the sum, as n equals 0 to infinity, of, how would we write inside of our sum? What would that be? The power of n, right? So we can actually distribute in our n if we would like, and we could rewrite our f of x as the sum, n equals 0 to infinity, of negative 2 to the n times x to the 3n. Okay? So that is our power series for f of x, for Maclaurin series, right? Now we want to do a power series for f prime. So let's take the derivative of that. I want you to think, if this is our f of x, how would we take the derivative of that? What would that derivative look like? Take a minute to think about that. Maybe check with your group, and then we'll check in. So f prime would be the sum as n equals 0 to infinity. How would we write that derivative? What would we do with the negative 2 to the n? Do we do anything with it? No, because we consider it as a constant, right? So I have negative 2 n times, and then x to the 3n. How would I do that derivative? X to the 3n minus 1. There isn't really anything to cancel out, so that is our power series. We could move the 3n in front if we wanted to. We could also write an expanded form. We can plug in some of our terms to kind of see what does it look like. So if I plug in 0, I'd have negative 2 to the 0 times 3 times 0 times x to the 3 times 0 minus 1, so that'd be to the negative 1. And then we would have plus negative 2 to the first times 3 to the first, or 3 times 1, right? And that'd be times x to the 3 times 1 minus 1 would be squared. And then plus, we would have negative 2 squared times 3 times 2 times x to the 3 times 2 minus 1, which would be the fifth. All right, so this first term would be 0. Our second term, we would have a minus, end up being minus 6x squared. And then that one would be positive 4 times 6, so 24. So plus 24x to the fifth, plus dot, 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 and we would have all of that, right? But then that would be our answer. So that would be our derivative. All right, any questions on that problem? All right, let's go ahead and turn the page, our last page. So this problem is a culmination of a lot of the different things that we've seen for the last little bit. Part A, so we're given a series for f of x. Part A, we want to find our interval of convergence for f. So that means we need to do our ratio test and do a to find the radius of convergence in our center. Then we need to test our endpoints to be able to find our interval of convergence for f. Then we are going to determine the interval of convergence for f prime and the interval of convergence of the integral of f of x. All right, so let's start with part A. We're going to be having a lot of stuff in here, so try to keep things a little small. So we start by doing our ratio test. What do we do for our ratio test again? So it is the limit as what? N goes somewhere, someplace. Infinity. Absolute value of, yes, what? A of n plus 1 over A of n. So we're going to go ahead and do that for this problem here. So we're going to start out with that limit. And remember, if our A of n is a fraction, we can just start out by multiplying by the reciprocal, right? So we're going to go ahead and do the limit test. The limit as n goes to infinity. Absolute value x to the what? N plus 1 over times n over x to the n, right? All right, let's go ahead and rewrite things and cancel some stuff out. So we have the limit, n goes to infinity, and that would be x to the n times x times n over n plus 1 in parentheses times x to the n. So what cancels, guys? X to the n. And what can I bring out to the front of my limit? X goes out front. So we have equals absolute value of x times the limit as n goes to infinity of n over n plus 1. What is that limit equal to according to dominance? To what? 1. And so then 1 times absolute value of x would just be absolute value of x. Now, for this to converge for the ratio test, what must that be? Less than 1. So we go ahead and say, hey, we're going to have absolute value of x is less than 1, which then makes me have negative 1 is less than x is less than 1. So that means our radius of convergence is 1, and our center is 0. And we have our 2 endpoints. Are we good so far, guys? So let's go ahead and test our left endpoint. What is our x value for the left endpoint? Negative what? 1. Let's go ahead and plug it in. So that is going to be the sum, n equals 1 to infinity, of negative 1 to the n over n factorial, or over just n. All right. What series test would we use? Yeah, I would want to use, I have an alternator there, so let's use the alternating series test. So what do we do first for the alternating series test? The limit as of, so just 1 over n. What do we want that to be? Equal to 0. Is that equal to 0? Yes. Okay, what else do we need to do for the alternating series test? So I have 1 over n plus 1, and what do we have to have that? 1 over n. Is that true? Yes, it is. So if it's true, then what do we say? Does it converge or diverge? Converges. So we can say it converges. And we have the test that we used. It converges by that alternating series test. Okay, let's go ahead and do our second endpoint. What is our second endpoint? 1. All right, so let's go ahead and plug that in. So that'd be the sum, n equals 1 to infinity, of 1 to the n over n, which is just the sum of n equals 1 to infinity of 1 over n. So what test are we going to use here? I heard some of you say it. The p-series. I want to use a p-series test. What is our p in this case? And what do we need it to be? Or rather, if it is equal to 1, what are we comparing it to? What's the inequality that we are comparing it to? It is less than or equal to 1. If we are less than or equal to 1, do we converge or diverge? That one diverges. Do we remember the name of this series? Harmonic. This is our harmonic diverging series. All right, so do we have our interval of convergence, ladies and gentlemen? Interval of convergence, what do we have on the left-hand side? Comma, 1, and then parentheses. All right, so there's our interval of convergence for that one. Okay, how are we doing so far? Good with that one? All right, so now we need to find what is f prime of x and determine its interval of convergence. Now, I mentioned again at the beginning of today that if we go back to our very first page of this lesson, what do I have highlighted in yellow? It says the radius of convergence is what? Is the same. So, do we need to do the ratio test again? No. So that's nice. We don't have to do that ratio. Once we've done the ratio test once and figured out our radius of convergence, we don't need to do it again. However, is the interval of convergence going to be the same? Not necessarily. Could it? Possibly. Is it necessarily? No. So we are going to still have to test our endpoints. So we're still going to need to use our convergence tests. So let's go back to that problem. We know that our radius of convergence is going to be 1, but first, let's go ahead and figure out what our f prime is going to be. So our f of x is the sum, n equals 1 to infinity, of x to the n over n. So then what is f prime? How do we write f prime? So I have the sum as n equals 1 to infinity. What do we have on the top of our fraction? The n minus 1 over. All right, does anything cancel? the n's. All right, so then we're left with the sum n equals 1 to infinity of x to the n minus 1. So that is our derivative function. From it, our radius is still 1, our center is still 0, and our endpoints are going to be -1 and 1. Okay? We are able to use this same stuff down here as well, and end up being on the last one as well. Okay? So let's go ahead and test our endpoints. So x equals -1. So that one, I'm going to have the sum as n equals 1 to infinity of -1 to the n minus 1. What test are we going to use? We can start with alternating. What is the first thing that we need to look at with an alternating series test? The limit as n goes to infinity. Really, it's the piece without the alternator, which is 1, isn't it? Well, what is that limit equal to? Is that equal to 0? No. So, remember back to when we did our alternating series. If the limit does not equal to 0, what do we then say? By the what test? Nth term test. So it ends up that we say we are diverging by nth term test. All right, so that's the left-hand side. Let's check the right-hand side. X equals +1. So this one is the sum as n equals 1 to infinity of +1 to the n minus 1. Well, what is 1 to any power? So that is just the sum as n equals 1 to infinity of 1. What test are we going to use? If you ever have something like that, it is still the nth term test. And we end up having the same thing. Limit is equal to 1, which is not 0. So what happens here? Diverges by what test? By the nth term test. All right, so do we know what our interval of convergence is going to be? What are we going to have on the left? Parentheses, -1, comma, or parentheses, right? So, are these interval of convergences the same? No. In the first one, we were able to include the left endpoint. We can't here. So that's where it was talking about on the first page. The radius of convergence is going to be the same, but the interval might differ. All right. Any questions on part B? Let's do part C. All right, so let's go ahead and do the integral of f of x dx. So that means we're going to be doing the integral of the sum, n equals 1 to infinity, of x to the n over n. Remember the very first problem we did yesterday, I can pull everything out that does not have an x. So I'm going to go ahead and say, hey, I have the sum as n equals 1 to infinity of 1 over n times the integral of x to the n dx. All right, so then I have the sum as n equals 1 to infinity of 1 over n times, what is the integral of x to the n? X to the n what? Plus 1 divided by n plus 1. Okay. Plus c. Yeah, it was an integral, so I have a plus c. So then that is equal to c plus the sum, n equals 1 to infinity, of x to the n plus 1 over, and I can distribute and multiply those, n squared plus n. Are we good so far, guys? All right. What is our radius of convergence? Still 1. What was our center? And so the interval endpoints are still going to be -1 and 1. And what are we going to need to do for each of them? Test them. So let's try it out. 5 minutes left. We should be able to finish this up. So let's start with x equals -1. Plug that in. We have n equals 1 to infinity. The c in this case, when we're doing our interval of convergence, the c isn't necessarily going to affect that because we're taking things to infinity. So you don't need to worry about that plus c. You do want to have it there in your integration, but when we go to test our endpoints and write out our interval of convergence, it's not going to cause much to happen. Now, if we are given an initial value, we can solve for that c, usually, but in this case, we don't need to worry about it. Okay, guys? All right, so let's go ahead and plug in our -1. So that's going to be -1 to the n plus 1 over n squared plus n. What test are we going to use? Let's start with alternating, right? So let's start with that limit. Limit as n goes to infinity of everything without the alternator, 1 over n squared plus n. Does that equal 0? Yes, it does, so we're good there. It does not diverge by the nth term test. Let's move on. So then the second piece we need to check is our a sub n plus 1 being less than a sub n. So we have 1 over n plus 1 squared plus n plus 1. Is that going to be less than or equal to 1 over n squared plus 1? Is that going to be a true statement? Yes, it is. So what happens on the left-hand side? Converges. We can say by alternating series. Test. All right, so we're good on that one. Let's go ahead and look at the other side. So x equals +1. So that's going to be the sum as n equals 1 to infinity of 1 to the n plus 1 over n squared plus n. All right, so that's just going to be the sum as n equals 1 to infinity of 1 over n squared plus 1. What test can we use? P-series is going to be part of it, but this is not a P-series. If we do the nth term test, it's inconclusive because that's equal to 0. So you technically could use integral tests. I would not recommend it though. There's two that we tend to forget. Whenever you see something like this, the one you want to use is the limit comparison test. Okay, so that's what we're going to use. Use limit comparison. Now, the one that we are going to compare it to is a p-series. So we're going to compare it to n equals 1 to infinity of 1 over n squared. Our p is equal to 2, which is greater than 1, so it converges. So let's set up the limit. So that would be the limit as n goes to infinity of, and we would have 1 divided by the other. So 1 over n squared plus n times n squared over 1. Well, that is going to be the limit as n goes to infinity of n squared over n squared plus n. What is that equal to? 1. For this, we need it to be finite and positive. Is that finite and positive? Yes. So, since the comparison series converges, then our original series converges. Okay? And thus we know what our interval of convergence is. Okay. So I'm going to finish that out. If you want to stay and finish it out as well, you are more than welcome to do so. So our interval of convergence would be bracket -1, 1, bracket on that one.